Hello, and today we're going to learn how to evaluate composition of inverse trig with regular trig using triangles and the unit circle setup. All right, so let's take a look at what one of these problems might look like. Sine of the inverse cosine of 7/10. All right, if this was a value like a half or root 2 over 2, you'd be able to do this without using right triangles, but because they're special right triangle coordinates. But this is 7/10 doesn't ever pop up in something that's memorized. So we need to look at a little bit more of an involved process. All right, so first let's figure out what's happening here. Inverse cosine is restricted to the first and second quadrant. Because this is positive, that means that this angle must exist in the first quadrant, because in the second quadrant all of your x values are negative. All right, so 7/10, so something a little bit less than 1. Let's just draw what that angle looks like. It might look like something like that. Okay. Now what we're going to do is we're going to drop down the y value here, creating a 90-degree angle. So now we have a triangle. And that angle right there is the solution to this little tiny inside problem. So let's blow up that triangle so we can get a better look at it. This angle is the solution to the inverse cosine of 7/10. Okay. We don't know what the value is. We're not going to know what that value is for a while, but our goal is to figure out what is the sine of that angle. Alright, well, let's set up some stuff that we know. We know that if we take the cosine of an angle, we end up getting the adjacent over the hypotenuse. So, because the cosine of this, or the inverse cosine of 7/10 is this angle, that means the cosine of this angle has to be 7 adjacent over 10 hypotenuse. Okay, we're missing this side over here, which is equivalent to the y value of this coordinate. We can figure out what it is, though, using Pythagorean theorem. 10 squared is equal to 7 squared plus y squared. Alrighty, so this is 100, this is 49. If you subtract them from both sides, you get 51 is equal to y squared. So y is equal to positive and negative root 51. Depending on which quadrant this triangle is in, y could be positive or negative, but because we're in the first quadrant, my y values are all positive. So this is positive root 51. All right, now let's go back to the problem that we had. Sine of this angle. Sine is opposite over hypotenuse, so sine of this angle would be the opposite, which is the square root of 51, divided by the hypotenuse, which would be 10. And there you have it. There's your evaluated expression reduced to a ratio of two numbers. So this whole thing is equivalent to square root of 51 divided by 10. Okay, let's look at another one. We're going to throw negatives in there. So tangent of inverse sine of negative 4/5. All right, let's start off by remembering what the restriction for inverse sine is. It's first and fourth quadrant. And the first quadrant y's are positive, and the fourth quadrant y's are negative. So this angle must be a fourth quadrant angle, something like this. Okay, let's make that right triangle so that we can expand it and work with it. Alrighty, so that angle right there. Right, the sine is opposite over hypotenuse. The y value here is negative, so notice how this is negative, right? Negative 4/5. That's because this 4 value right here is a negative y value, negative 4. It's in the fourth quadrant. Your hypotenuse, though, is still going to be 5. Alrighty, we don't have this side right here. It's really the x value of this coordinate, so let's call this x. Let's figure out what that x value is. It's a special right triangle, but just for ha-has, we'll do Pythagorean theorem. X squared plus negative 4 squared is equal to 5 squared. So we have x squared. This is positive 16, and then this is positive 25, so if you subtract them from each other, you're going to get 9. So x is equal to positive and negative 3. In the fourth quadrant, this x value, all the x values for this would end up being positive, so we're going to use the positive 3. Okay. All right, so we're trying to find the tangent of that angle that we've created that represents the inverse sine of negative 4/5, because for this angle, the sine of that would be negative 4 over 5. All right, tangent would be opposite over adjacent. The opposite to this angle is negative 4. The adjacent would be 3, so negative 4/3 is your simplified value for this expression up here. Okay, let's do one more. The secant of inverse tangent of negative 6/5. Okay, so first again we need to remember inverse tangent is restricted to the first and fourth quadrant. Because it's negative, the ratio of x to y's are negative in the fourth quadrant. So this angle right here that this stands for has to be a fourth quadrant angle. And again, we're going to make it a right triangle by connecting it there. Let's make this a little bit bigger so we can play with it, and that's the angle we're looking for. So we're trying to find the secant of that angle. Let's define the triangle with respect to what this angle has to be. So this angle gives us that the tangent is -6/5. Tangent's opposite over adjacent. In the fourth quadrant, my x values are positive and my y values are negative. So that negative is going to go with the y value. The y value would be 6, so it's going to be -6, and the x value should be positive 5. There we have it. Tangent of that angle would be -6/5. Okay, and we got to figure out what the hypotenuse is before we move on. So let's do this. Is 5 squared plus -6 squared is equal to, let's call this h for hypotenuse, h squared. So that's 25 plus 36 is equal to h squared. This is 61 is equal to h squared. So h is equal to positive and negative root 61. We usually use a positive value for the hypotenuse because the hypotenuse really, in the grand scheme of things, is the radius of the circle, which just notationally we usually call positive. So we're going to call this a positive root 61. All right. Secant. Well, secant is a reciprocal of cosine. Cosine is usually the adjacent over the hypotenuse. The reciprocal of that would be the hypotenuse over the adjacent side. So instead of being 5 over root 61, this is going to be root 61 divided by 5. And there's your answer. Alright, so now hopefully you have an idea of how to build a triangle in the circle in order to evaluate inverse trig and trig composed so that you can find that value without using those memorized coordinates for the special angles. Alright?